Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we're the Backyard Musings, the Science and Technology channel.
Yeah, and we are talking about a health issue this morning, and it has to do with a plant and plastics. So let's just get into it.
Yeah, if this can work, man, this would be great. A common plant seed could be a powerful new tool against microplastics in water. Researchers in Brazil have identified a surprising ally in the fight against microplastic pollution, Moringa oleifera. A study carried out at the Institute of Science and Technology of Sao Paulo State University in São José dos Campos found that this plant, also known as moringa or white acacia, can help remove tiny plastic particles from water. Would you like to know more?
Yeah, this is fascinating. I don't know how they came up with this, but it's pretty cool. The findings were published in ACS Omega on January 19th of this year, a journal of the American Chemical Society. Moringa originates from India and thrives in many tropical regions. Its leaves and seeds are widely consumed due to their nutritional value. I never even heard of this plant before. Scientists have also been exploring the seeds for years because of their potential use in water purification. Moringa seed, the saline extract generated from coagulation necessary for filtering microplastics.
So we've got
That's
Scott and I have a picture we're looking at. I didn't put it on in a slide presentation to throw it up here because it was just one slide. But Scott, doesn't this look like one of those big banana plant things that has seeds in it? You know what I mean?
well,
I
yeah,
don't know if I'm making
yeah.
sense.
When I first saw it, I thought it was maybe some type of an olive tree or an olive branch.
Yeah, it looks like the leaves are olive. Yeah, definitely.
Yeah, and
But
then when I saw those little seeds, I thought, well, maybe those are kind of like a white olive. But then
it's
I don't
like
know those
it's like in a
pods.
12-inch pod, right?
Yeah, yeah, and that's when I noticed that because that one pod, there's a couple of them there that look like they're closed, and then
Yeah,
one of them looks like it's split open in half, and you could see the seeds in half. So
yeah.
yeah,
And
and it also reminds me of the seed pod. I think I'm calling it a pod. Is that if that's correct? We have desert willow trees that grow crazy out here, just wild, you know. And it looks like the pod of a desert willow, and the
hmm,
seeds look about the same too as well. But the leaves are
hmm,
not. The leaves I thought again were olive.
yeah.
So interesting.
So here's a quote here. We showed that the saline extract from the seeds performs similarly to aluminum sulfate, which is used in treatment plants to coagulate water containing microplastics. In more alkaline waters, it performed even better than the chemical product, says Gabrielle Batista, the
Hmm.
first author of the study. She completed the research during her master's degree in the postgraduate program in civil and environmental engineering at the Boro School of Engineering at the University of Sao Paulo thing. Yeah.
That's interesting. That's kind of what our issue around here with our groundwater is, alkali. Um, and I wonder if it would work here. Interesting. The research was led by Adriano Goncalves dos Reis, a professor at the ICT-UNESP and in the PPG-ECA at FEB-UNESP.
You're making that up, man. You're
I
making
don't
that up.
even know what all that is, but if it's some kind of code, okay. I hope I don't
It's the
just didn't
school.
set
The
something up.
school.
Yeah. He also directs the project Direct and Inline Filtration for the removal of microplastics from drinking water, supported by FAPESP. That's
You
quite a
think
name.
you think these people are in the Navy with all these acronyms. Crazy.
Yeah.
All right, quote, the only drawback found so far regarding aluminum sulfate was the increase in dissolved organic matter, the removal of which could make the process more expensive. However, on a small scale, such as on rural properties and in small communities, the method could be used cost effectively and efficiently, says Reese.
Okay. So Well, that would mean you could use that on probably like a ranch or a farm.
Yeah,
Um,
like out in San Joaquin Valley, in Fresno area where all those farms are.
right. The study focused on a process called inline filtration. In this method, water is first treated with a coagulant, which destabilizes suspended particles, and then passed through a sand filter. This approach works best for water with low turbidity, meaning it's relatively clear and does not require extensive pretreatment.
Coagulation is a critical step because microplastics and other pollutants carry a negative electric charge. This causes them to repel each other and prevents them from sticking to filtration materials like sand. Coagulants such as Moringa salt extract, which can be made at home, and aluminum sulfate neutralize this charge. Once neutralized, the particles cluster together into larger groups that can be removed more easily during filtration.
Earlier research by the same team showed that moringa seeds are effective throughout a full treatment cycle, including flocculation, sedimentation, and filtration. Luis Gustavo Rodriguez Godoy, the first author of the study, completed his master's degree at the FEB-UNESP with funding from FAP-ESP.
To evaluate the method, researchers added PVC polyvinyl chloride microplastics to tap water, which is not very difficult.
Right.
PVC was selected because it is considered one of the most hazardous plastics for human health, with no mutagenic and carcinogenic effects. And you can probably tell by the way my eyes glow that that's true. It is also commonly found on the surfaces of water bodies and can persist even after standard treatment processes. Nasty.
Yeah. The team exposed the PVC to ultraviolet radiation to simulate natural aging and replicate the characteristics of real-world microplastics. The contaminated water was then treated using coagulation and filtration in a jar test system, which mimics water treatment on a small scale. The results were compared with water treated using aluminum sulfate.
To measure effectiveness, the researchers used scanning electron microscopy to count microplastic particles before and after treatment. They also measured the size of the clusters formed using a high-speed camera and a laser. Both methods provided similar levels of microplastic removal.
The team is now applying moringa seed extract to water taken directly from the Paraíba do Sul River, which supplies São José dos Campos. That must be in Brazil, I would imagine, right?
Yeah.
So far, the results show that the method is effective under real-world conditions. Okay.
Quote, there's increasing regulatory scrutiny and health concerns regarding the use of aluminum and iron-based coagulants as they aren't biodegradable, leave residual toxicity, and pose a risk of disease. For that reason, the search for sustainable alternatives has intensified, Reese concludes.
These findings suggest that moringa could offer a more sustainable and accessible option for removing microplastics from drinking water, particularly in smaller communities where cost and simplicity are important factors. So,
Moringa seed.
yeah.
Love it.
And we were just talking before we got on, the PVC pipe is, there's miles and miles and miles of it in the ground here supplying water to homes and apartment buildings, commercial buildings.
Sounds like a class action lawsuit to me.
Yeah, it would be widespread, I'm sure. And what are they going to attack? They're going to attack the pipe manufacturing companies. That would put them out of business. There's not that many of them. So tough deal.
All right, folks, thanks for joining us, and we appreciate it. Smash that subscribe button, and tell your friends, your neighbors, your enemies, and your family.
Yeah, we're very grateful. And you guys have a great morning. We'll see you this afternoon. Thanks.